Good afternoon, everyone. Glad you could come. This is a 2-hour presentation, and let me introduce, first of all, my cohorts. On my left is Matt Fiddler. He's a security researcher and security professional. And on my right is Tobias Bluzmanis, my co-author in the new book we came out with on Medico high security locks. Matt and I will be generally doing the presentation this afternoon, although I think Toby will make some comments as we go. This afternoon we're going to talk about, our lecture is really split into 3 components, and we'd urge you to stay for the full 2 hours or hour and 50 minutes. The first part we're going to talk about the methodology that we used and what we learned about cracking Medico high security locks. The second part, we're going to talk about what we perceive as a real threat that's resulted from the design of the 3rd generation of Medico high security locks and what kind of trouble you can get into by toying with patents and current designs. The third part of our presentation will deal with ethical disclosure, responsibility, and what we call irresponsible non-disclosure, which is a flip side of responsible disclosure. So we think you'll find the material interesting, perhaps in the second part a bit shocking. We did invite representatives of Medico to participate with us in this panel, as we've done for the last 3 years at DEF CON. And we actually heard from the senior management that we deal with at Medico this morning, apologizing they could not be here. It's really a shame because it would have made a terrific point-counterpoint presentation. We also heard from the executive director of BHMA, which is the Builders Hardware Manufacturers Association, which is a group of lock manufacturers that derive standards, security standards, and Ralph Vasami, who's their executive director, a very good guy, very knowledgeable. He also could not arrange his schedule to be here, but said otherwise he would have been pleased to be here. So basically what we're talking about today are real-world threats, real-world issues. If you're involved in security, risk assessment, risk management, facility protection, you really need to understand the risks involved, the potential vulnerabilities that you can encounter in high security locking hardware. This lecture is a result of 18 months of research that really the 3 of us conducted into Medico high security locks, and which obviously culminated in a release of a book. And so we're going to go through a rather lengthy slide presentation and a number of video segments, and then hopefully at the end we'll be able to entertain some questions if we have time. Matt?
Great. So we'll start at the beginning. So why is this case study important? For us, it's continued insight into high security locks. We'll discuss some of the issues associated with patentability and the fact that there aren't assurances associated with patents, appearances versus reality, and ultimately the manufacturers and their claims and reliance on the standards organizations like Underwriter Laboratories or ANSI BHMA. We'll get into, as Mark said, responsible disclosure, or as we call irresponsible non-disclosure, and manufacturers' representations thereof. We'll go into detail the 18-month research exercise and our attacks, and offer up suggestions for secure lock designs.
So we're talking about, first of all, conventional versus high security locks. For those of you that may not be totally conversant on this subject, essentially conventional security locks are easy to open by bumping and picking and the compromise of their key control. There's limited forced entry resistance. Most of your residences, lots of businesses, they use conventional locks. They really have very limited security. In contrast, high security cylinders are UL and or BHMA listed, which means they go through or are supposed to go through rigorous testing to ensure that they're secure against different types of entry. And so they're higher quality, higher tolerance, and they have multiple security layers. You typically pay 2 to 4 times more for high security locks than conventional locks, and they're not supposed to be able to be opened easily. So high security locks, where do we find them? Basically, critical infrastructure, high value targets. And this is why you put them in. We use these locks where the threat level is higher, where you anticipate more knowledgeable or sophisticated attackers. Everything from banks, jewelry stores, public infrastructure, government facilities, nuclear, and obviously locks aren't supposed to be the only layer of security, but in many instances they may be. And so the locks in any event are usually the first line of defense. So that's why we buy high security locks, and that's why we're talking about this subject today, because of the many vulnerabilities that we've derived.
So for high security locks, there's 3 critical design factors. They need to be, and we really detailed this last year or the year before at DEF CON, all the standards and the associated requirements. But they need to provide resistance against forced entry, against covert and surreptitious entry, and what's key to our presentation and demonstrations here today is key control, or what we call key security. But unfortunately, there are vulnerabilities associated with each requirement.
Go ahead.
So high security locks offer multiple security layers. There's more than one point of failure. Often they're integrated and react at the same time. Some operate in parallel, and often it's difficult to derive intelligence or information from one or more of the security layers.
So in our research project, we developed an attack methodology that's really applicable to all high security locks. And the first rule is assume and believe nothing. The high security lock manufacturers, and some of whom we do consulting work for, will represent their products as absolutely secure, virtually pick-proof, virtually bump-proof, virtually immune to attack. Some of them will tell you what the real world is, some of them won't tell you, and some of them, frankly, don't know. And so we developed a methodology when we began our project to ignore all of our associates and experts in the field and to really think out of the box. And this is really important because, for example, my co-author, Toby, has been a locksmith for more than 25 years and has been a medical locksmith, that is, works on medical locks for more than 10 years. And if you had told Toby when we first started this that these locks could be picked in as little as 30 seconds or opened by forced entry means in as little as 30 seconds, or that you could completely compromise their key control in seconds, he would have said you're crazy. And that is the problem, and a lot of locksmiths in the United States really believe this because they don't have the ability to do their own research. Very few are embarking on the kind of research project that we engaged in. So the bottom line is, look with skepticism when somebody tells you a lock can't be picked, or it's very difficult to pick, or it's very difficult to bump, or it's impossible to bump. So you also always have to believe there's a vulnerability. As many in this room can attest that specialize in opening locks, if you don't think you can open the lock, you're probably not going to do it. If you have a mindset that you can open it, you'll get it open more than likely. And what we really did, we worked the problem. For almost 40 years, everybody said medicos are invulnerable. They're such a good design, so innovative, they cannot be opened. Well, or with very, very limited success with complicated and sophisticated tools. And so we just kept working the problem. So there are really 2 primary rules in attacks. The first is the key never unlocks the lock. Now, this may seem odd or a statement that nobody understands, but at the end of the day, many locks can be opened by a variety of techniques that does not rely on the key. It's mainly mechanical bypass. And so that's the first rule. The key really doesn't unlock the lock. The key controls the mechanism that unlocks the lock, the bolt, the latch, whatever. So if you can get directly to that mechanism, as we did, for example, in the deadbolt attack that we disclosed last DEF CON, then the key and all of its security means nothing. The second rule was expressed by Alfred C. Hobbs, and it basically says if you can feel resistance or contact between internal locking components, you can likely open that lock. And so those are really two fundamental principles that guide us in attacking and attempting to develop vulnerabilities or discover vulnerabilities in locks.
And the second, you'll see we implement opposing forces and interactive components within the Medico system to ultimately bypass the locks. And you'll see that in the video demonstrations.
So methods of attack high security lock. There's a lot of methods to attack locks. Picking, impressioning, decoding, vibration, shim wires, magnetics, wrapping, air pressure, audio. There's many, many ways to attack high security locks, or normal locks for that matter. Many of these have been disclosed in Europe and specifically by Tool. There's some really neat new attacks on electronic locks. And so nothing is sacrosanct. And again, the rule that y'all have to understand and remember is take with skepticism all the claims. And additional methods of attack, simulating sidebar codes, use of a key to probe the depths, rights amplification of keys. There's many, many, many different approaches to attacking a lock. And this is why we've supported the lock sport community over the years. It's much better than chess because it involves mechanics, it involves mental imagery, and it involves a lot of understanding. And so what you need to really realize is there's a lot of different ways of attacking the problem. Go.
So exploiting features, and this really dives into our methodology of attacks. Critical to the Medico design was their codes, their code book, their design, their progression. You need to understand the key bitting design, what tolerances exist in the lock. John King and Skylar Town in the previous session in talking about the Medicoder really got into the tolerances and the associated vulnerabilities that those tolerances bring into play. Keying rules, there's been a lot of talk over the last couple of years about top-level master key extrapolation. As we said before, the interaction of those components and how to leverage one against the other. And as we'll get into in part 2 of key security, the keyway and the key design.
Go ahead.
So standards, we spent a lot of time with this at DEF CON's past, talking about underwriter laboratories, BHMA, the high security lock standards. But at the end of the day, many of the lock manufacturers rely on these standards and ultimately rely on the time factor associated with bypass of high security locks.
And I think it's really interesting to insert at this point. There was an article, if you haven't seen it, on CNET at news.com, the latest one that was published about a week ago. And a senior Medico representative was quoted as saying that companies should rely on independent testing agencies like UL to discover vulnerabilities. Well, that really raises interesting issues that we're going to talk about later, and that is we think these companies ought to have in-house or consultants that are really capable of looking at their locks outside of the box and making these determinations. The problem with UL and BHMA and our assessment is they test for very specific issues that are defined in the standards. It's like Catch-22. And if it's not in the standard, they don't test for it. When we broke the deadbolt last year on Medico, which forced them to institute 2 fixes to deal with the issue, UL refused to look at a complaint with regard to that problem because it wasn't in the standards. And so the bottom line is the standards really are lagging way behind in providing the protection in these locks that they should.
And I think the key word there is contemplate. So they don't even contemplate future attacks or vulnerabilities. And another quote within that article talked about how us and you should not be responsible for finding those, but that the standards organization should be. Keep in mind, again, our previous presentation, we talked about the types of tools, the size of tools, not to exceed X number inch screwdriver, hammer, etc. They're very specific requirements.
So the standards address for the high security locks under the Builders Hardware Manufacturers Association, there's 3 real criteria for high security locks: covert and forced entry resistance and key control. Now, UL does not address key control. They do address forced and covert entry. And so there's pictures here of cylinders that have been drilled out that are contemplated in the standards. And then conventional picking attacks, which is covert entry, are also defined in the standards. And essentially, in America, the standards require resistance of 10 minutes or 15 minutes, depending on the security level, against picking attacks. Then there's sophisticated decoders. This one was released a long time ago by John Fall in Europe. It was very sophisticated at the time. It's about a 6/1000th of an inch wire that's used to decode the internal components of the lock. And so this was state of the art 15 years ago. And in a couple minutes, we're going to ask John King to come up for a 3-minute summary of his Metacoder. But this tool prompted the introduction by Metaco of ARX pins, which are being re-implemented 15 years or more later to stop the use of the John King Metacoder. And so it's not exactly new technology, and actually all of this goes back 30 years to the lock technology case, which was really the first decoder for Metaco. Metaco sued the company. Metaco actually lost the lawsuit, but the company was put out of business. And so there's all kinds of decoders out there, and the next one will tell a little story. This is my favorite story. No? No. This is Toby's decoder that he first came up with to decode Metaco locks. And he contacted me a couple years ago as a lawyer. This is a very neat piece of work. He was unaware of certain decoders that had been available for the government years before, so he conceived all this in his head. And when he asked me to take it to Metaco to see if they might be interested in this decoder, and their answer was, "You mean that crackpot from Miami?"
So if you need to reach Toby, it's crackpot@security.org.
Yeah, you can make a note of that. And
this other alternative email address also. Don't use that one, please.
So that's how actually this all started in our research project, a little bit of history for everybody's enjoyment. So there's also ways to decode these locks. These were shots that are in the book on decoding pin angles by sticking a 9/10 of a millimeter borescope right through the keyway to read the pins. And so this is all documented, but this is another method of bypassing locks through covert entry. So forced entry resistance, Matt, why don't you talk about this photograph?
So this photograph is showing a Metaco cylinder, and where my mouse is, I don't know if you can see that. These are anti-drill pins that are inserted into the lock to prevent against the previous slide pictures demonstrating forced entry attacks or drilling attacks.
These are the top 3 pins at the front of the plug by the key.
Additionally, Metaco cylinders employ crescents, hardened steel crescents to prevent drilling. And as John King talked about, many of the ARX pins incorporate hardened steel inserts to prevent drilling of the individual pins and pin stacks themselves.
And forced entry attacks in the standards, we won't dwell on this, but there are many types of attacks that are defined, and there are just as many that aren't defined or not contemplated. And our problem is that we were able to develop, once we started looking at forced entry with Metaco, we were able to develop 4 different types of forced entry attack that are really not contemplated in the standards, are serious. Some of them are exceedingly simple to execute. And our problem is, and what we're pushing for is a change in the way standards are written and defined so that they will protect all your facilities. That really is the end goal here. So sidebars. Modern high security locks, most of them employ what's called a sidebar, and so we looked at different methods to bypass sidebars, because in the case of Medico, it is their patent, and as we'll do one of the slides, the sidebar is Medico security. It's all about the sidebar. If you can get around the sidebar, a Medico is just like any other conventional pin tumbler lock. And so that's really a critical issue. The sidebar gave us all the trouble in breaking the Medico locks. So we had to figure out how to go after that sidebar. Matt?
So for the Medico cylinders and other high security cylinders, there's direct access to compromise of critical components. The Medico deadbolt, there's been 1 and 2 specific attacks against that. There's our latest release that we'll get into on the forced entry attacks later in the presentation, manipulating the tailpiece. This was released, the first attack against the first generation last year at DEF CON.
That was a 30-second attack to open a lock that's essentially guaranteed to resist forced entry for 5 minutes by the standards. 30 seconds or less.
And so the hybrid attack, there's a couple different methods that we'll demonstrate here, a reverse picking attack, picking, bumping, and others, as well as a significant flaw in mortise rim and IC cores, defeating the shear line of these locks.
When you want to bring on John?
The non-disclosure session.
All right.
Go ahead.
So go ahead.
So Medico case history, obviously, we exploited the vulnerabilities, looking to attack this. We were able to reverse engineer their sidebar codes, and this is critical. The sidebar is Medico security and those codes. Analyze the tolerances, all the control issues, and design enhancements that were made to extend the patentability of the M3 and Medico line, and the ability to exploit those extensions to the technology, new features, new functionality that was added, and use those against the law.
And I'd just like to make a comment, and we'll talk about it again. This issue of patents to protect these locks is really what you're paying for in key control and proprietary security technology. So the problem is, in Medico's case, and this is one of the real lessons that everybody needs to understand, and we hope that the high security lock manufacturers pay attention. The problem is you start monkeying with designs, because patents are good for 20 years. If your lock isn't patent protected, companies won't buy it, or the government won't buy it if it doesn't have legal protections to stop people from opening them for key control. And so patents are really prized so nobody can knock off your products. So the original Medico lock came out in about 1970. It was a brilliant design. It was actually a takeoff on a 1935 design of the General Motors automobile lock, which employed a sidebar. But they figured out, 2 guys in a garage in Salem, Virginia in 1968, started a little company called the Mechanical Development Company, which then they synthesized to Medico. They figured out how to rotate tumblers and integrate a sidebar into a pin tumbler lock. So the relevant issue here is the original patent, and we think that's probably their most secure lock. Amazingly, they ought to go back to it. Seriously, and we've suggested that in the book. There are issues in the original lock or security in the original lock that don't exist in the biaxial, which is 2nd generation, and the M3, which is 3rd generation. And so they came out in about 1985 with what's called the biaxial, which we refer to as Generation 2. And it was a radical departure, and it was very, very clever for increasing the number of key differs or the number of key combinations that were available in the lock. But it also brought in security vulnerabilities. and caused all kinds of keying rules to be implemented. Then in 2003, their third generation, the M3, which is the lock with the slider that met the famous paperclip that we introduced last year. Well, the problem is that when they redid the patents or modified the locks the second time to get another 20 years, so when the life cycle runs, it'll be a 60-year-old product. Right now it's 40. It's a 40-year-old lock with no real security enhancements. The problem is that they've really decreased the security twice. And this in part allowed us to compromise these locks. Go ahead.
So Medico mistakes, and certainly there were quite a few. They failed to listen. Throughout this 18-month research exercise, they've been appraised of information provided, samples, everything for the entire project was provided to them. As Mark just described, there are embedded problems from the beginning, and critical to the design failures of the M3, extending that patent, introducing that slider, introduced new problems to the system.
Yeah, and I'd just like to comment, and they were really my friends at Medico, and we hope someday they'll be again. We really briefed them and provided them with everything that we had for 18 months. We told them what we thought the vulnerabilities were. We told them what our assumptions were. We asked them repeatedly, tell us why we're wrong. Tell us why we can open your locks and we shouldn't be able to do it. Is it a random occurrence? What's the deal? So they wouldn't tell us. And so we just kept developing more technology and kept opening their locks. And it was really, in the end analysis, a failure of imagination and an understanding of certain bypass techniques, especially if they really do adhere to theory, let UL find the problems. It's not the way to do it, and not by the leader in North America in the high security lock industry. They own at least 70% of the market. The real problem is they can't open their own locks. That's really the problem. And so they really didn't connect the dots. And we've tried to be not really critical, but they should have listened. Go ahead.
So back to the design equaling the vulnerability. We'll get into the internal components of the Medico design, how the sidebar and sliders work, the tolerances that we're able to exploit, the biaxial design, fore and aft positioning that was, I'm sure, gone through in detail in John King's slide, as well as the deadbolt design. But again, as Mark stated, it's not only their failure to understand the problem and understand the bypass issues. He said they were not able to duplicate what we provided them, tools, techniques, and instructions, and they couldn't reproduce the same attack.
Yeah, they just said this is all nonsense and it's not true and there's nothing in these locks. And this is really a critical reason for lock sport. This is a critical for independent research and analysis of locks. At the end of the day, if a lock is designed properly, the manufacturer should not be concerned about who is trying to break it. If there's a problem, fix it. If there's no problem, you're not going to open it, or you're not going to open it in a timely fashion, which means there's no security vulnerability. So exploiting design vulnerabilities, basically, to sum up this slide, we took the best design features of the Medico lock, which was embedded since the original patent, and we figured out how to use those design features against the lock to open it. And so we use the way the sidebar leg is designed and the way it integrates or interfaces to the pin tumblers. We looked at their code books because the first generation lock and the second generation and third generation had entirely different codes because of the way the pins were designed. That difference in code, and whoever the mathematicians and cryptographers were that derived those codes, they allowed us to break those same codes. And so we looked at all the designs, and we also looked at their slider design in their 2003 third generation, and we figured out how to methodically break each layer of security. So the Medico timeline, as I said, 1970, the original lock, about 1985, the biaxial, 2003, the M3, which is the current generation. And that's really important for y'all to remember, because the M3, as we're going to show you in the next hour, is really, really vulnerable to a very simple method of attack.
So we're going to talk about why they're secure, and I think the three of us sitting up here truly believe that these medical locks are great locks. It's a great company, they're great locks, but there are flaws and vulnerabilities associated with them that you need to be aware of, and you need to assess your own security and your own requirements for protection. So they incorporate 2 shear lines and a sidebar in the biaxial model. In the M3, they introduce this notion of a slider. There's 3 rotating angles with 6 permutations. False gates. John talked in depth about ARX, anti-pick pins that close off the channel where the sidebar mates and interacts with the pins, and they're extremely high tolerance locks.
Yeah, they're very good locks for most applications. So this is a normal pin tumbler. This is a conventional pin tumbler. All the bottom pins are aligned at shear lines, so the plug with a key in it right now is free to turn. This is a medical biaxial cutaway that we did, and the plug is turned about 10 degrees. You can see all the bottom pins have a channel, the lavender arrow, number 4. And number 3 is the sidebar leg that actually it enters that gate. And when all the legs enter all the gates, the sidebar retracts and the plug can turn. So there's 3 independent security layers in a Medico M3 cylinder: the shear line, the sidebar, and the slider. Now, and each of them have their own parameters, and each of them really operate in parallel, which means independently, which means that if one fails or 2 fail, the third one should still keep the lock from being opened. Unfortunately, this is not exactly the case. So Medico twisting pins, which is what their patent is all about, this is a biaxial key with lines drawn, so it shows, unlike a normal key where all the cuts are parallel, these are all different angles, and the combination of angles is what we call the sidebar code, a term that we coined so everybody would understand a common language what we're talking about. So the collection of angles is different for each system. All the angles within a system are generally the same, all the angle combinations. And the bottom cylinder here shows a key. The bottom of the key has been marked in red. This is a milled out cylinder, so you can see, why don't you zoom in on that? So you can see what the pins look like if the key were stuck in the lock. And you can see that the angles are different on the pins, and they match the red lines on the key on the left side of the plug. So basically, what happens when you stick the key into this lock is the pins are rotated as well as being lifted. That is the security of a Medico cylinder. So again, we won't dwell on this, but sidebar technology, it blocks rotation of the plug unless all the pins are rotated to the correct individual angles so the sidebar can retract in the plug and it can turn. That is what the sidebar does in almost all locks in one form or another. So in certain locks like the ASA and the Primus, Schlage Primus, and the EVA magnetic code system, the sidebars are really independent locking systems that are controlled by independent bidding on the key. If you look at a Schlage Primus, for example, there's 2 sets of cuts, one that's in the side of the key and one that's the conventional vertical bidding on the key that raises the pins up and down. This is really critical to the discussion that's coming up in a few minutes about how we violate their key control and obliterate it. Because a lot of these high security locks, you cannot do that because of the design of the way they made the keys. So sidebar locking, it's very simple. Most locks have 1 sidebar. A lot of them have 2 sidebars. And again, there's a second set of pins or rotations that control that sidebar and how it retracts into the plug. Unless the sidebar retracts, that lock isn't being opened.
And this last bullet is really key to some of our findings, setting that sidebar code and being able to manipulate the lock through picking or bumping, and a new method attack that we'll demonstrate in a video here, which is a reverse picking attack where we're actually able to pull the plug forward without turning, which is a typical technique when picking a lock to apply tension to a cylinder to bind the pins. We're applying that tension laterally and pulling the plug forward.
Go ahead.
So information from the lock, A.C. Hobbs talked about deriving intelligence or information from interactive components, feel picking, the ability to sense what's going on, the ability to leverage magnets, a whole host of interactions that can be decoded or interpreted from feedback from the lock.
Okay, so again, in a Medico cylinder, the sidebar is Medico security. And unless you can manipulate that sidebar so it retracts into the plug, you will not open the lock covertly. Okay, so this is a photograph of the plug and sidebar. All of the pins are aligned. Zoom in on that. So this is what the plug looks like when the key raises all the pins to shear line and all of the pins are rotated so that the sidebar legs can go into the gates of each individual pin. Next. So this is the same picture with one of us putting our thumb on the sidebar, pushing it into the plug. So the sidebar can be pushed all the way in, so there's nothing to stop this plug from turning when it's inside the lock. And this is, in contrast, would be a locked plug. The sidebar could not retract. The key is actually pulled out here a little bit. The pins are in the shell, in the plug, and the angles are different. So this lock could never be opened. Go ahead.
Why don't you talk about the code book?
So also at the heart of Medico security is their code book. And the code book derives or specifies all of the usable codes for the vertical bitting and the rotation angles. So all the locksmiths in the world have to use this code book for all non-master keyed systems. And the new code book came out in about 1983, 1985 when the biaxial was introduced. It's the same code book for the M3. And these are only codes for non-master keyed systems. The factory usually does the coding for master keyed systems. So the relevance here is we broke that code book. We computerized it, we analyzed it, and we figured out the codes so that we could figure out how to simulate the codes for the sidebar and open the locks. So go ahead.
So the results of the project, this is really what we've been leading up to. Covert, surreptitious entry in as little as 30 seconds. Forced entry, many techniques, more than 4, 30 seconds or less. And a total, complete compromise of key control.
Total. Okay, so this is the M3 slider. This was their 3rd generation, and their patent claims another layer of security. Well, evidently we didn't know about Mr. Paperclip.
The MacGyver
and Matt, I'll let you address this slide because this is outside my realm.
Mark didn't know who MacGyver was, so we had to educate him. So we're going to show a quick demonstration of bypassing a slider on a Medico M3 with the paperclip. Actually, a piece of wire.
And it just turns out that the slider is offset by 40 thousandths of an inch, which happens to be the normal diameter of a normal paperclip. And so when I saw this in 2003 at the factory, pre-production, my friend at the factory said, here's what we've come out with. What do you think? I said, I think it's really neat, but I think there might be a problem. And he looks at me rather exasperated because we've been doing this for many years. Like, why don't you leave us alone? And why, go pick on somebody else. He says, well, Clyde, because you're the big target. And I said, he says, there's 26 different sliders in these locks. So what the hell is the problem? And I said, the problem is that all of the sliders are the same length. There's little steps on the slider, but all of the sliders are the same geometry. So if you offset the whole slider, I don't care what the key does. I can do it with a paperclip. So go ahead, roll the video.
We're going to form the paperclip that locks into place to position the slider properly. And this is just a standard 40 thousandths inch diameter, approximately, paper clip
That is
that you can buy at any office supply store. Okay?
okay. To form that special tool that we're going to do to
Special
bypass the third element that blocks the medical M3,
Well, it's actually not a special tool.
we're going to bend the wire 90 degrees. Okay. With that portion up, we're going to bend it again,
The paper clip's a high security tool.
and it's going to look more or less like this. Now, if you notice, this portion is too big, but we're going to cut it in a way that is going to help us.
This is just a standard pair of
So you're going
vice
to put a
grips.
sharp point on the edge,
Yeah, that you can
so
do
it
it.
can wedge into the between the slider.
Not necessarily, but it helps. So once we have that
Toby,
shape,
by the way, grew up in
we
Caracas.
can look. Actually, let me put this
I
down.
love this picture.
Right there, we have the slider completely bypassed. So we have one element bypassed by the wire or the paper clip.
I'm going to just pause this here because basically, so what Toby's done is he's introduced this paper clip right before the slide bar, bypassing any of the possible 26 steps. What we're going to show you now is a simulated key created on a key blank that has the correct vertical bitting
And the correct angle.
and the correct angles. But because the slider is bypassed, this key that's been simulated doesn't have a slider step on it. So just watch.
And the other two elements in the key. When we put all those elements together,
Just like a
we can
factory
bypass
original.
the lock.
So that tool, that MacGyver multi-tool, effectively made this Medico M3 a biaxial.
So it eliminated the third security layer. Okay.
So the results of the project in picking, as we said, picking in as little as 30 seconds, leveraging standard picks, no special tools. We can use another key in the system, a change key or some other key with the correct sidebar code, one of the code setting keys. All that's required is to pick the pins to the shear line and neutralize the sidebar.
And let me just make one other comment. A 18-year-old kid in Colorado that works for a Medico lock shop bought our book when it first came out a couple weeks ago. He sent me an email on Wednesday when he got it. He says, I can't stop reading this. I can't go to sleep. It's great. Friday, 2 days later, he sends me an email. We're sitting at dinner. Toby and I are in Miami. He says, I think I cracked your codes. He says, could you verify these codes for your four code-setting keys that'll open all the Medico locks? Well, they weren't exactly correct, but they were close enough. But then he went on, so he called me. And he told me that after he figured out how to make the code-setting keys, he picked the lock on the front door of the lock shop in 55 seconds as an 18-year-old kid. And he said, I told my boss, and my boss really didn't believe it because he's been a Medico dealer forever. This is a real problem. And so this is really what we did in our code-setting key concept. 4 keys for all pre-December 2007 Medico cylinders and some much later if they haven't been pinned to the new codes. 4 keys will allow you to pick or bump all of the virtually all of these locks that are non-master keyed.
Okay, so we're going to show a quick video, and just as an introduction, this video was created with a cutaway lock that's mounted in a vise, and Toby's going to be picking this lock. He's actually, rather than leveraging a tension wrench or tensioner tool in the lock, he's using the cam on the back of the lock to provide tension.
Yeah, so he's twisting the lock, but it's exactly the same thing, and we cut the channel on the bottom of the lock. So this is the underside of the keyway, so that you can see, this is the same photograph as we did earlier, so that you can see the actual angles as the pins are set in the lock. So this is just the way they'd look when the key is inserted to the right angle. So now, and Toby's best picking time is 27 seconds on a 6-pin Medico cylinder. Mine is a couple minutes because I don't pick locks as often now as Toby does, and because he's a working locksmith every day. And so what you're seeing is the pick tool at the bottom of the keyway manipulating each one of these pins.
And you're seeing this after the sidebar has been set, so
Yep.
that's an
We've neutralized the sidebar as he's picking this lock.
We have set the sidebar code.
And we've neutralized the
Slider.
slider also. So there's the pick.
1,
1,
2, 3, 4.
and these are mushroom pins now.
And 6.
And it's open.
And the lock is open.
That is a standard, off-the-shelf, 6-pin Medico cylinder. That is not under the standards allowable. Period. So when my friend at Medico says we should allow UL and other standards organization to test for vulnerabilities, that's why we really respectfully disagree with the statement. They don't even have a clue about the ways we've developed in opening these locks, and they're used in 70% of the facilities in the country.
So this is a new hybrid attack. As we mentioned previously, it's reverse picking. So by leveraging design vulnerabilities associated with the lock, we're able to set the slider with the paperclip, wrap that around a screwdriver, and apply lateral or outward tension rather than rotational tension that would typically be applied in picking a lock, and pick this lock and pull the plug forward.
Yeah, so let me just make a couple comments, because this is really a novel technique that we actually call this pulling the plug on Medico, just to maintain our sense of humor. Everybody thinks that when you pick a lock, you have to apply torque to the plug either left or right. That's the conventional way of picking a lock. And when you do that, you bind the pins so that as you push each pin up, they get trapped at shear line. And when all the pins are trapped, the lock opens. Okay, so we looked at this problem once we figured out some other forced entry issues and vulnerabilities, and we figured out, well, why can't we pull the plug forward and apply torque as the plug is being pulled out of the lock so that the pins bind at the back end of the pin rather than at the side of the pin? There is no difference. So the video we're going to show you is we're applying reverse pressure on that plug to pick it. And that's why obviously we call it the reverse picking attack.
So again, a couple pieces of information from this video have been edited. We've removed the ability to set the sidebar code. And then we just basically cut to the end after it's been successfully picked and removed. And you'll see.
You have to understand that on this forced entry, we're a little bit sensitive about it, and so we have withheld publication for the last year, and it's not in the book. It's on the CD version with regard to certain forced entry techniques that are required. They're very simple, but they're required in order to accomplish the rest of the steps. So Toby is picking the lock. He's using a screwdriver wrapped around a paper clip or a piece of wire that's grabbing where the slider is to put reverse torque on the plug. So he's actually leveraging that plug forward and picking the lock so he can pull it.
The plug has moved forward. Okay. On his strap. So we're going to remove this tool.
Very sophisticated tool.
And now I'm going to pull that plug.
This is a standard pair of vice grips.
But all the components and all the pins.
And then you can stick a screwdriver in and directly access the tailpiece, and the lock is open. So that was another forced entry vulnerability that honestly, none of the standards organizations have contemplated, and this is precisely the problem. We've been advocating, why don't we write standards for 3 security levels, low, medium, and high, and it really doesn't matter how you open the locks within a specified time frame.
So bumping, we demonstrated this here at DEF CON as well. We can reliably bump biaxial and M3. We can produce bump keys on actual blanks, simulated blanks, and leverage this attack with a known sidebar code or no intelligence at all.
Yes, and so this is our bump key. This is a special bump key that we designed. We have actually 4 of them to bump open, again, all of the pre-December 2007 and some later locks. Now, this is cut on a specific blank for a keyway, but we can also do this on a simulated blank. This is a very different looking bump key than you'll find for normal locks that we introduced 2 years ago. And this is the bump key that Medico says cannot work, that their locks are bump proof or virtually bump proof, as we'll talk about, or virtually resistant.
So we have some video demos. If I could just get a quick show of hands, who hasn't seen the General In video? Quite a few.
Okay.
Right.
This is the little 11-year-old and 12-year-old that we made a star at DEF CON 2 years ago and last year, who we walked into the lock-picking village, and she's bumping open locks 2 years ago, quick sets. And then last year, we handed her a bump key that we had prepared for a Medico high-security bump-proof cylinder. And as you'll see, she opened it in about 1 minute and 20 seconds. And the company said this is impossible, so we suggested
So what did you do?
watch the video.
So what I did was I bumped this lock by putting the key inside, and you then put just a little tension, and then you hit it with the hammer, and then it took me a few times before the key actually turned and it opened.
And how many times did you do it?
I wasn't counting.
Are you willing to give it another try on camera?
She was very
She
nervous.
probably won't be able to do it because she's nervous.
It's up
She
to
can
you.
try it. You can try it. Go ahead and try it. Oh, you want your bump
She didn't like my
Official.
bump hammer.
Okay.
So she figured out how to do this. So she takes the key out and puts it back in again. And I was a little bit surprised.
There you have more video proof of it.
So we sent that lock.
That is, now there's a number 2. Oh, you turned it, you locked it. There's a number 2 on this that we've identified the cylinder. This is going to be sent for analysis tomorrow to another expert. And but you saw it.
Saw it right on video.
Right on video.
So, first of all, she had done this several times, but she was really nervous. We're going to be up in the lockpicking village for the weekend. We do have special Medico biaxial profile cylinders that we've set up for researchers to understand how this works. And some of them you can open in 5 seconds, 10 seconds. They're 5-pin, brand new biaxials. But these locks are definitely not bump-proof. And as we'll talk later, even with ARX pins, we can bump them open. So, go ahead.
So I had to explain.
This is more of your cartoons.
Ponies as well. Unfortunately, we weren't nominated for the Pony Awards, but if we were, I think it would have been pretty interesting. But the top-level master key extrapolation, again, we don't have demonstrations of this. A lot of this is restricted information, but a total compromise of the top-level master key system within the Medico locks. So forced entry attacks, again, there's been 3 revisions of the deadbolt design after last year's DEF CON release. We mentioned the hybrid technique of reverse picking forced entry and the mortise and rim cylinder and IC-specific locks for forced entry.
So this was the deadbolt attack, and again, this is a sanitized version. But at the end of the day, a modified $2 screwdriver is capable of opening all the deadbolts with the specific design that Medico came out with for the M3s, some biaxials, prior to the fall of 2007. And again, this was not contemplated in the standards, and in fact, UL and BHMA wouldn't even look at this issue because it was not defined in the standards as this method of attack.
So this is the high-tech tool that was designed to bypass. So as we said, there was the original attack. Medico released an interim fix immediately after DEF CON last year, and they subsequently introduced the third generation fix. And this video demonstration is against the latest release or incarnation of their deadbolt design.
Well, actually, it's the interim. It's the interim version. The reverse picking attack is the final version. It's a great picture.
There's no way to apply end pressure to this bolt normally. However, if we insert our screwdriver and apply torque, we can then easily push the bolt to the unlocked position. This procedure can be employed on an outward opening door where access to the deadbolt is available. An ice pick or sharp-pointed knife can be used to push back the bolt and compromise the cylinder.
So that was their interim fix, and then they came out with their final fix late fall of 2007, which rectified that, but allowed us to develop our reverse picking attack. So, and we should make a couple comments. The Medico Bi-Level is their latest clone. It's a low security Medico lock that does not have a real sidebar in it. And if your facility is using these or you're contemplating using them, you really ought to understand the security vulnerabilities that we lay out, because the entire system can be compromised by looking at bi-level cylinders. They really are not secure. They're for internal doors. They're easy to open. So go ahead, Matt.
So just in summary, we're able to reverse engineer the master key system. We have 4 keys that are able to simulate sidebar codes for second generation code book. Able to set the sidebar code. The wider keyway, as we'll explain in the key security, opens up a whole host of vulnerabilities associated with
which is coming
these
in a few minutes.
And the paperclip offset.
Okay, so these are the 4 keys to the kingdom that we developed that'll open all the non-master keyed cylinders. Now, these happen to be for a specific keyway, but as I said, we can simulate these blanks to accomplish the same thing. Patents have actually been filed for this technology for setting the sidebar code using code setting keys for picking and bumping. So, now we're going to come to the fun part. Key control and key security. Go ahead.
So as we said in the standards mandate certain restrictions on key control, that they can't be duplicated, replicated, or simulated. And lock manufacturers introduce a whole host of technologies, regional sidebar milling, restricted keyways to prevent duplication simulation of keys.
So, and this is what key control is supposed to be all about. You can't get the blanks. If you're a government facility or a bank or a major medical facility, you do not want employees or anybody else to be able to go get copies of your keys if they're restricted or proprietary. Just like the White House, for example, they have their own keyway, and so nobody else can get it. And that's the idea of key control. So if you can compromise key control, you really own the system. So we're talking here about real-world threats. As you'll see in a few minutes, this affects every Medico M3 cylinder that they've made because of the way they changed the patents. And it also affects a number of biaxial cylinders. Go.
So obviously keys, while the key never unlocks the lock, it is the easiest way to open the lock via change key, master key, bump keys. But keys are protected via the standards. We talked about side bit millings that are existing in Primus and ASA cylinders. They're interactive elements like the multi-lock interactive that has a floating pin to it, use of magnetics, and a whole host of additional components that are added to protect keys.
So owning the system, obtaining the critical data. So how do you get key data? And I must say that my friend Barry Wells, who's here today from the Netherlands, and Han Fei gave a great lecture a few weeks ago in New York about this same topic and really introduced the topic. And so we're taking it a little bit farther today. How do we get information? We can do impressioning, decoding visually, and key gauges, and borescopes, and photographs, and scanning keys, and copy machines. Go ahead.
So the critical element of keys, there's the length, the number of pins, sliders, discs, the variables associated with that. What is the height of the blade or thickness? Whether or not there's paracentric keyways, whether or not the wards in those keys cross the imaginary center line and prevent or obstruct some foreign entity from entering that keyway.
Like a lockpick, so that it's difficult to move anything vertically in that keyway, which is the idea, which is why the standards require certain keyway designs.
And the introduction of additional modifications like finger pins in the Schlage Primus or sliders.
So this is about key control. This is an M3 key on top, the latest key, and you see the little step on the bottom that controls the slider. The bottom key is one of our metal keys that we made to simulate this key. Both of these keys will work in the lock, as you saw in the earlier video. But we went much, much further. We actually embarked on simulating keys because we had to be able to do all the different keyways to make bump keys and code setting keys to open these locks. Because otherwise, you'd never accomplish this, because a lot of these keyways are proprietary or restricted. One of the reporters asked us last night, why didn't you guys figure this out a couple years ago? What's the matter with you? Well, what's the matter with us is we had a different perspective because we were looking at solving different problems.
So we're going to talk in detail about duplication, replication, and simulation of key control, and specifically key security. So key control is the physical protection of keys. Again, I'm trying not to be redundant here, but it's important that you understand the standards, the requirements that are introduced upon manufacturers to protect those keys, protect you as a consumer and the infrastructure. They control the generation of keys. There's patent protection, and we'll go into this in detail.
So this is the Medico key control, and it's appearance versus reality, and you're all going to have to judge. And by the way, there's a Wired magazine article that just hit the net about 2 hours ago that covers this in depth. What is it supposed to mean? Are the standards sufficient, and real-world vulnerabilities? Now this, if you can't read it, says do not duplicate. So is this the key control? You guys draw your own conclusion as we proceed here. Can't duplicate it. Read it.
High security starts with key control, a process that ensures that keys cannot be duplicated without proper permission. Clearly, if anyone can have a lock's key copied, then it truly doesn't matter how tough the lock itself is built. Medico's patented key control makes it virtually impossible for someone to duplicate a commercial or residential key without proper permission.
Now, this is taken from a brochure that Medico issued in 2005, which we can only assume is still active and relevant. So this is statement number one. Go ahead.
Goes on to read, a standard key can be copied at 1 million stores without restriction or proof of ownership. Unauthorized duplicate keys often result in burglaries, theft, vandalism, and even violent crimes.
So that's what we're talking about in the real world, and here's what's coming.
Just show you a quick demo that reinforces this fact.
Could you, copy this for me?
Sure.
I've been babysitting these kids for a couple weeks now. Their parents totally think running errands.
But in a few minutes, I'm going to have a copy of your front door key. And in a couple weeks, I'm just going to walk right in and help myself to whatever.
Wait a minute. This is a Medico key. Only a Medico locksmith can make a copy of this. And only with the key owner's permission.
Now, you got to remember this video. So you're all anticipating what's coming. So, Medico key control, the problem. The problem is that we can circumvent each of their security layers. Their keyways can be bypassed, their blanks can be simulated, their sidebar codes can be simulated, and the sidebars and the sliders can be bypassed. So there's no real protection except for the M3 step, which can be bypassed by a paper clip. And so as we go through each security layer, all of a sudden the lock has no protection. So, key control, duplication, replication, and simulation of keys. This is a keyway diagram that we did for the book with showing the center line of the keyway. Now, under the standards, the wards are supposed to cross that red line so that you can't do this. This red line is the same thing as a blank key or a cut key being inserted into that keyway. So, go ahead.
So we're going to go through duplication, replication, and simulation. So improper acquisition or use of keys by employees and criminals. And what we're going to really talk about is the insider threat. So someone who has unauthorized access to facilities, they can create bump keys. They can use those keys for rights amplification, a top-level master key extrapolation, and totally compromise the master key system. They can replicate. Again, Barry Wells did an amazing presentation at Hope that talked about silicone casting, using bismuth alloy for metal casting of keys, plastics, epoxy, totally duplicating and refabricating real facsimiles of keys.
Everybody knew that conventional keys could be easily replicated. It's not a problem. Go ahead and you can answer that. So everybody for many, many, many years understands what makes a key, and that pin tumbler locks can be easily circumvented given specific keyways with everything from metal to epoxy. What they didn't really contemplate is bypassing certain high security locks. So go ahead.
So this just goes on to say, the additional design features and functionality inherent with the M3 to extend that patent allowed us to simulate those keys.
So basically, we have a total failure of key control, or of what we prefer to call key security. So we can go through, as we'll show you in a couple minutes, we can totally bypass restricted and proprietary keyways in the M3 and some biaxials. We can get around the M3 slider with a paper clip. There's a serious sabotage potential with that same paper clip to lock you out of your own system. This is what wasn't contemplated when they developed the patented technology for the M3. Availability of blanks is not an issue, as you'll see. We can duplicate keys from pictures or codes. We can extrapolate the top-level master key. Go ahead.
So from our perspective, there is no key control or key security. Again, we can do this on all M3s and some biaxials, restricted and proprietary keyways that are restricted to certain locksmiths. The M3 step, as we showed with the MacGyver multi-tool, is absolutely no security. We can copy and produce any blank, generate that top-level master key, and cut any key by code.
Go ahead.
We'll just. No. This is. Skipping over this, we'll post all these slides online, but this is the hybrid attack that is detailed in the government version against mortise rim and interchangeable core cylinders.
So all of these locks are at risk. There's millions of them. And there's really a design problem that we perceive allows us to really rapidly open these with certain inside information. So this is the new threat that we perceive, keymail. This is emailing of your key from inside a restricted facility to somebody outside to make the key. And this is what the Wired magazine article is about. It's a dangerous threat. It can affect millions of cylinders. It is a total failure of key control. And as I said, all of the M3s virtually and some biaxial keyways. And it's use of the new multifunction copier that scans, copies, prints, and allows the production of Medico keys. Keymail.
So the premise is we can easily capture an image of your key. We can then replicate that key in plastic. And there's a couple different methods that we can leverage to open that lock. And you're probably saying to yourself, okay, I can do this already with my Quickset or some other standard. This should not be capable in a high security lock.
Absolutely not.
And it's a very, very simple technique.
And it's not contemplated by the standard. So we'd like to announce that Medico accepts plastic.
So again, it works by, you need access. This is an insider attack. You need access to that key. You need it for 2 seconds. You capture an image, you print the image, you produce a key, you open the lock. And some of our key catchphrases from our vendors.
We always try to maintain our sense of humor here. We're not sure that Medico has, but we have really attempted to. So which one do you like the best? Don't leave home without one. What's behind the locked door? Priceless. Go anywhere you want to be. The card that can get you cash or the card is key.
And that's actually Diners Club's, claim to fame. The card is key. So we agree.
We absolutely agree.
So you need to cut a facsimile of the key. In this specific hybrid attack against mortise, rim, and interchangeable cores, all we need is a two-dimensional photograph copy, picture of the key. We don't need sidebar data or slider data. All we're doing is raising the pins to shear line.
Now, this picture, by the way, can you zoom in on that, Matt? This picture I shot of a Medico key, and the little cut marks are with an X-Acto knife. This is actually a two-dimensional image. This was done on an HP scanner copier, $150 copier. This was printed on a piece of address label and then imprinted on plastic. Go ahead. And it's a simple matter to cut out the key. This is Medico key control. This is a Medico key card that's issued to protect their keys from improper replication or duplication. So we took the Medico key card and we cut it out and made a key and opened the lock.
Sweet. So the procedure, again, obtain an image, scan, copy, photograph, use that little etching with the crayon and the piece of paper like you did with leaves in school. Email and print that image remotely. Again, this is an insider attack, and I want to stress that. You need to then ensure that you have a one-to-one image. You can print it on paper, on labels, or my favorite, Shrinky Dinks. Shrinky Dink, I don't know if anybody remembers those when you're a kid. You basically just color an image, cut it out, bake it in the oven. We are not baking these in the oven.
Now, and I want to make a comment about Shrinky Dinks because we talked to them. It just so happens that this company in Wisconsin has been around for about 35 years. Great company. They make this special plastic that you can print on. And then it'll expand when you put it in the oven. Well, we don't need to put it in the oven. We just wanted the print-on portion. So we take the plastic, if we want to use Shrinky Dinks, and we cut out the plastic and we make a key that'll replicate the vertical bitting on the lock. Now, the plastic credit card, the plastic, we can actually replicate the angles also, so then all we have to do is use the paper clip to bypass the slider. The folks at Shrinky Dinks were rather upset at this prospect and said, look, you can't talk about this. This is, well, why not? We're using your plastic. No. Our company is built on magic, imagination, and creativity.
And so are we.
And I said, ma'am, it sounds to me like those are all the key ingredients that are lacking at Medico. I said, maybe you guys ought to get together. She says, oh, my God, don't talk about us. Everybody's going to think we're condoning breaking into buildings. She says, ma'am, we're not. That's the farthest thing from the truth. I'll tell everybody, you guys are not condoning your plastic to be used for unlawful purposes, but this is a valid research project, and it just so happens that you make the plastic that really works neat. Shrinky Dinks. Go ahead.
So again, there is one critical skill, high tech. It goes back to kindergarten, and it's your ability to stay in the lines and cut that image out.
Yeah, it's really, really difficult. Go ahead.
So then ultimately you insert that key that you've created, duplicated, simulated, insert it into the plug. And for mortise, rim, and interchangeable cores, this hybrid attack, this is all that's needed to open the lock in several seconds. So again, insider attack, you need access to that key just for a second. Whole host of ways that you could get it, but produce an image of that key, email it out of your facility, capture it on a copier, scanner, fax, cell phone. Here's one technique. Here's another.
This is the HP scanner copier that I use to make that key, and this is a piece of shrinky-dink material. Okay, this is my BlackBerry Curve that I use to capture an image of the key that I made a copy of that I used to open a lock. Now, this is actually the image, and nobody believes you can do that with a 2-megapixel camera on a BlackBerry. Well, you can do that because this is shot through a magnifying glass. And as you can see, that's an excellent image.
And not only is this image representative of a two-dimensional picture of this Medico key, but if you look closely, you can see the shading on the bitting that will actually yield information to the rotational angle of those cuts.
Yes, as we demonstrated last evening. So, should I talk about that right now?
Yeah, go ahead.
The reporter that wrote this story spent a lot of time on it. She went and bought a Medico cylinder in San Francisco. She then went to a Kinko's store and emailed me a picture of the key. It was not a one-to-one picture because evidently the scanner wasn't working properly. We got the images. Toby and I compared the images, decoded the key, and Toby produced a piece of plastic. Last night we met with a reporter, inserted the key in her lock, and opened it. It had the angles, it had the vertical bitting, and that was the end of the story.
It was literally,
3 seconds.
Uneventful. She's like, wait, stop.
Yeah, stop. We have to document this. No, your lock is open. Now, we thought we were going to have to use a forced entry technique to do this with that key, but we got the angles. And so this is real world threats. This was done remotely. Anybody could do it. It's not that difficult. Now, decoding the angles, it's a little more difficult, but replicating the vertical bitting on the key, no problem.
It's trivial. And then this is just, use your own imagination, but we're able to do it on paper, credit cards, plastic. My favorite, shrinky dinks. Toby just did one also for this reporter's keys on a piece of copper wire.
We thought that was appropriate for wired. So Toby actually took a piece of wire, flattened it out, made the key, opened the lock. Yeah, we have some pictures of that.
And a simulated metal key, as we showed before. So here's another picture of printing it on plastic or paper. Again, this will open M3s and some biaxials. A standard key machine could be leveraged. A Medico cutter, a hand cutting, X-Acto knife, a whole host of techniques.
The real issue is it's not difficult. It's not complicated. So everybody can understand this threat as opposed maybe to bumping and picking, which takes arguably a little bit more skill, and you have to have the right keyway for the lock. This doesn't require any knowledge of the keyway. It's just the vertical bitting.
But again, you got to stay in those lines.
Got to stay in the lines. It's critical. So this is a key that I made. This is a 20 thousandths inch thick piece of report plastic folder that all of us were down in Miami preparing, doing the final research for the book in May. So we're rummaging through the Office Max store looking for things. And we took this piece of report folder, cut it out exactly, and this will open the lock. What it is overlaying on the bitting. So it's an exact overlay. And again, these are different examples of plastic keys. This was traced. All of these keys will open the lock, but we actually like the credit card plastic the best. So this is a picture of the hybrid attack with a mortise cylinder with a piece of plastic. This will work with a mortise, IC, or rim cylinder. and on the left it's inserted, on the right it's turned. So this is a conventional lock. This is a quick set, my favorite. One layer of security. So we had a key, we produced a key for this to open this lock, and this we took a chase card. And this is the key up above. This is the chase card that opens that lock. This is a piece of cake. Now, this you expect in a conventional lock.
And when we opened up part 2 about key control, that's why I said you expect this.
This is the chase key. That's it. But we do not expect to be able to do this with a high security cylinder. Quick sets, no problem. Okay, so in contrast, we have a Schlage Primus on the left and an Oss on the right. They both have what we call side bit millings. Why don't you zoom in on that, okay? These keys you cannot replicate in plastic the way we're doing with Medico because they're totally separate parallel systems. And so there's really no way to do what we're doing with a Medico cylinder with these kind of locks. So whether they thought of this when they designed the locks, Bo Whedon is actually the inventor. I never asked him about this, but these locks are secure against this form of attack. They have real key control.
All right, so we're going to show a couple video demos. A Medico key being cut on a actual Medico key machine, as well as plastic being leveraged on a door.
So this is a MasterCard key, priceless.
Remember to wear eye protection.
And this is the little wire that we'll use to bypass the slider, okay? So now Toby's going to trim the plastic residue off the side of the key. Here's a comparison. And the lock is open. It takes MasterCard. Okay? No problem. It's trivial. This is not supposed to happen. This is an M3. That's the key that opens this lock. It's provided by Medico. There's our favorite paper clip. There's a Medico. Yes. And we're using a small little vice grip to actually turn the plug.
You could use a tension wrench.
Use a tension wrench, screwdriver, whatever, but piece of cake. No problem. Okay. Go ahead. So here's what we advocate to protect your facility. I'm sorry. Go ahead.
You obviously can read as well as I can. No paper clips, no First Amendment.
You can't talk about security vulnerabilities. That's the first rule.
No,
don't tell anybody and they won't know about it.
No shrinky dinks, no X-Acto knives, printers, copiers, faxes, scanners, cell phone, email, fax connections.
No links to the outside world. You might post that. So, here we go to part 3, locks, lies, and videotape. Go ahead. Now, Medico announced after Jenna Lynn opened the quick set by bumping in 2006, our locks are bump-proof, virtually bump-proof, and virtually resistant. It gets a lot better. So, about the same time that Matt and I gave our presentation in 2006 here at DEF CON, and right after Barry Wells and I were in New York at Hope, Medico came out with their press release that said, our locks are bump-proof. August 4th or 5th, there you go, okay. August 4th or 5th, 2006. So, go ahead.
Well, if we want to bring up John briefly, and we'll talk about
Okay, yep. So then we'd like a 3-minute summary, if John will come up, to just give us a summary of what transpired with his Medicoder. And then, because we're going to talk about responsible disclosure for a couple of moments, and then show you why Medico hasn't exactly leveled with everybody about being bump-proof. Go ahead.
My name is John King. How many people here saw my talk right before Mark, Matt, and Toby's? Yeah? Okay. I'm going to give a brief summary. Basically, back in November, I developed a tool that turned out the technique it leveraged was quite old. But the tool was able to defeat the sidebar on Medico locks, original Backsteel and M3. We decided, myself and some of the Locksport community, that we wanted to release it. But first we thought we might get a reaction from Medico. And we were kind of expecting something like a lawsuit or a payoff. But we were pleasantly surprised that they were really friendly. They sent the director of research out there, Peter Field, out to my apartment. He saw the tool and said, this looks like a problem. So as a result, what they're doing right now is fixing all the locks coming off the assembly line by re-implementing a system called ARX to defeat this tool. Pretty much, they've been very friendly with us. Myself and NDE Magazine is the publisher I released through. But they have not responded whatsoever to Mark, Matt, and Toby's stuff. And you guys have seen a lot here. It's pretty impressive in my opinion. What do you guys think? Medico?
Okay. Thanks, John. So, responsible disclosure about the Medicoder. John went to them. We couldn't agree more. There's 2 editorials that are posted on our blog, in.security.org, that address the issues of why we think Medico embraced the Locksport community at this particular time. So, what's the responsibility, known vulnerabilities in Medico locks? Responsible disclosure versus what we call irresponsible non-disclosure. If there's serious vulnerabilities that are disclosed to Medico, we did that for 18 months. And they, as well as we know, have failed to disclose these issues to their customers. We really believe they should, and that they should tell everybody, okay, there's issues, and you need to know about them. Instead, there's been what we would perceive as misrepresentations, half-truth, and misleading advertising, and the use of language that means nothing. So we think responsible disclosure is a two-way street. We think if you discover a defect in a new lock or a new security system that hasn't been released, we think you absolutely have a duty to tell the manufacturer so they can fix it in a timely manner. The problem is locks are a little different. If a lock has been in service and there's an embedded base, then there's a real problem because generally the manufacturer is not going to pay to fix the problem. It's upon the consumer. As a matter of fact, Medico made a statement a couple weeks ago in a CNET article that said locks aren't like a subscription to a magazine or similar language, meaning go buy new locks if there's a problem. I don't really subscribe to that theory as a lawyer or a security professional, and I really believe, and Matt and Toby believe, that there's a responsibility on the part of manufacturers to tell you what's going on and disclose potential issues. Go ahead. Go ahead.
So the responsibilities of the manufacturers, for us, from a high security perspective, the responsibilities are very different. They do protect critical high-value targets and infrastructure.
These aren't like toasters.
And as Mark said, the responsibility lies upon the manufacturer to disclose these vulnerabilities to the consumers.
We think they just ought to tell all of these manufacturers if they have a known problem, they have a duty to tell their customer, and it can result in liability if they don't, both for the manufacturer and the locksmiths that sell them. So the real question is what to disclose and to whom, and there are two components, the public right and the need to know, and so it's security by obscurity, and it does not work. And that's because of the internet. In order for you to assume the risk and understand, you need to understand what the problem and the vulnerability is. Go ahead.
So again, the perspective or retroactive effect, Mark talked about this. If this is a newly discovered vulnerability in a not yet released piece of hardware, then absolutely you need to work with the manufacturer to introduce these details of the vulnerabilities and give them time. At the end of the day, though, it's a question of liability and cost. In a retroactive implementation, who's going to pay for that? Is that you, the consumer, or ultimately the vendor?
And our problem is when John went to Medico and they told him we're going to implement a fix in a couple months, that's all well and good. The problem was they knew about that issue at least 15 years before because they developed the pins to combat it. So the real question is, why didn't they implement those pins 15 years ago rather than implementing them now? And who's going to pay for them now to be implemented? Because you don't just stick them in the locks. You don't mail them out.
So we want to talk briefly about our perspective of the truth. Again, after we spoke in DEF CON, Medico introduced a press release where they claimed their locks were bump-proof. They retroactively edited that same press release to say they're virtually bump-proof. Yeah, I don't think Medico is aware of archive.org.
They probably will be after today.
So here's archive.org's representation of the August 4th press release. I'll try and zoom in here. You can read the third paragraph down. Medico is commonly known as a virtually... Oh, actually, I have the wrong one here. This is the...
2007, you have the wrong one.
The wrong one.
Medico is known as a bump-proof lock.
Bear with me here.
This is a Mac. Yeah, this is working really good, Matt.
Stop telling me what to do. Hang on.
Don't get nervous.
Not at all.
So there you go.
So I went too fast. This is the 2006 press release. I'm not going to zoom because I'll screw it up. Third paragraph down, Medico is commonly known as the bump-proof lock. We go to archive.org from February 2007. Medico is commonly known as a virtually bump-proof lock.
Now, they went back on their website and evidently changed the press release so that when all the search engines pointed to this, they'd come up with the new verbiage, which they again changed.
And ultimately, in 2008, this was a response.
So now the claim is we never said our locks were bump-proof. August 15th, 2006. This is called the smoking gun. They now claim we never said our locks weren't bump-proof. Everybody else said they were bump-proof, but we never claimed that. So August 15, 2006, for those of you that like to do research, the U.S. Patent and Trademark Office filing by Medico Security Locks, Inc. lawyer, Mr. Rothwell, the application is on the PowerPoint, the word mark bump-proof. And it was abandoned in February of 2007, sometime after we showed them conclusively that we could bump open their locks. So here's the actual filing with the Patent Office by Medico for the word bump-proof. So the question is, why would we want to protect the word bump-proof to use by Medico if they didn't claim their locks were bump-proof? If you can answer that, that would really be, we'd like to hear from you.
So the claims extend into picking, bumping. Nobody's proven in 40 years that they can pick our locks. These are false demonstrations. What we've shown you here today in these videos are smoke and mirrors.
Right.
We're lying to you. And they can't replicate the problem.
Except for the 18-year-old kid in Colorado now that opened the lock in 55 seconds after reading the book. That would be a problem. Go. So responsible disclosure by lock manufacturers. We just think that they have a duty to disclose if they know or suspect there's a vulnerability, that they should make responsible notifications and let the users and others assess the risk. They really have a duty to tell the truth, and this is the problem. Again, high-security lock manufacturers have a special place because of what they protect. Everybody relies on their engineering expertise and their integrity. They have to tell the truth.
So I hope you'll agree after this demonstration that medical locks are vulnerable. Again, you need to assess your own risk, your own exposure, what you're trying to protect, whether or not you should use these locks. They are good locks. Medico knows we provided them all the information, all the research, all the excerpts from the code design, progression, top-level master key, the book, everything. They are vulnerable to bumping, picking, forced entry. We believe they should be more candid with their dealers, their distributors, unlike how candid they were with the release of the deadbolt fixes. We believe there is a failure to tell the truth. And you, consumers, customers, people responsible for protecting critical infrastructure, have a right to know.
So again, there is no security by obscurity. It doesn't work with the internet. It's the user security. It's not Medico or your locksmith security. They have a right to assess their own risks. So criminals already have the information. Disclosure benefits, we believe, far outweigh the risks involved. Medico says our job isn't educating criminals. No, that's true. They need to educate everybody so that they can assess what their risks are, what other people already know. And there is a liability for a failure to disclose. So the lessons learned, nothing is impossible. Corporate arrogance, which this is a classic example, it doesn't work. High security lock makers, engineering, security, and integrity. That's what it's all about. So we would solicit, we have some time left, this worked really well. Does anybody have any questions or comments about the concept of responsible disclosure or anything we've talked about today?
And actually, if you want to come up, if anyone has questions,
does anybody have any questions? Why don't you come up? We'd really be glad to entertain questions. We think this should be a really good debate. We're really sorry that Medico could not be here today to engage in this, to present their side of the story.
So the question was, who funds our research?
That's a good question. Well, I have several legal clients that really are good about letting me do and retain anybody I want to do security research and vulnerability testing. And I also have some clients that specifically hire me and my associates to look at locks to protect themselves from liability.
Other than that, my wife helps to fund my research.
Yeah, right. There's a book signing at 3:15.
So the book is available. It's in your program. It's at 3:15. I think somewhere in the vendor area. There's some book. We got to find it. So help us find it. Other questions? You back there? Is there any evidence that people are attacking what? These locks.
No, we haven't heard any, but then we may not either. Usually in high security facilities, this isn't talked about, other than in the news a few weeks ago when the lady was sentenced for stealing $700,000. A controller, I believe, at Medico, who was working inside that stole $700,000. We hope that she didn't have Medico locks on her office. I don't know. But honestly, you wouldn't hear.
Go ahead. That's the question we always get. What is the most secure lock out there?
I have several answers. It depends when you say secure for what purpose. If it's really a high security facility, the last 5 to 10% where you really, really have to make sure they don't get in, we like Slag Primus, we like Abloy, we love EVA MCS, the magnetic code system. If you look on EVA's website, evva.com, they're in Austria, or we've showcased them in the book as the lock to compare to. Basically, for the EVA, if you don't have the key, you're not going to open the lock. Now, nobody says it's impossible, but if you don't have the key, you're not going to open the lock. Schlage Primus, Abloy, Kaba, Medico are good locks. It's just not good for all installations. And so, but those would be my answer. The Abloy, Primus, Eva.
Go ahead. Okay.
Yep.
Any other questions?
More questions.
Go ahead. So the question was, have any other lock manufacturers bought into our proposed methodology for disclosure? For disclosure and testing?
Well, actually, some of the folks that I work with are beginning to embrace this, and they've figured out that the best business policy is full disclosure. And I've had extensive meetings with Ralph Vasami, who's the executive director of BHMA in New York, the Builders Hardware Manufacturers Association, who have the real high security standard. They really are looking at this, and they want to do the right thing, and they're not bound by bureaucracy like we believe UL is. And they're seriously looking at this issue now, and they're talking to their members about disclosure. See, I think there ought to be disclosure on packaging to tell people these locks can be opened in seconds, to let everybody know. And everybody says, well, yeah, but then we wouldn't sell any locks. Well, that's the point. Tell the consumer what the vulnerabilities are and let them make the decision, or tell them, go buy better locks. Go buy higher security rated locks.
Any other questions? Go ahead. So similar to iDefense and other organizations, the question was, are there any incentives to exposing or disclosing vulnerabilities associated with hardware to lock manufacturers?
It depends on the vulnerability, what the penetration in the marketplace is, how serious it is, how easy it is to open the lock. It's a complicated formula. I've represented a number of clients in this area. My suggestion, first and foremost, well, first of all, if you can file for a patent, you file for a patent. And you can file for a provisional patent for $100 to protect the invention for a year. Then you go to the manufacturer and ask them to sign a non-disclosure agreement. If they won't do that, then it's a real interesting issue. Then it depends on the exploit. Maybe you can make tools. Maybe they're not interested. It is a complicated formula. I've represented several clients. Sometimes the manufacturers will want to work with you, sometimes they won't.
Question over here. Who do I contact at Medico to get my money back?
Let's see, 540-380-5000. That's a good question, and it may be raised subsequently. Well, they said you're not buying a subscription, so I guess you have to buy new locks. Well, that's a legal term, and whether it is or not is subject to discussion and probably later analysis. It's a very complicated area, and what happens from here, I'm not quite sure.
Question over there. Are they in the book? Is that the question? Yeah, so the question was, is the archive.org screenshots and associated details of the disclosure of the bump-proof, virtually bump-proof, in the book?
It's essentially all documented in the book. There's also a multimedia edition for locksmiths and government or security people.
Right here.
Given the large installed base of medical locks and the potential security vulnerabilities as demonstrated, is there sufficient capacity from the other lock manufacturers that Medico does not have to fix in time to replace all of the affected locks with higher security installations within, say, the next year?
So Medico has a lot of locks. This is a serious vulnerability and exposure. Is there sufficient capacity by other manufacturers to replace these locks?
Oh, I think they'd meet the challenge. I think if you contact Schlage or ASA or Kaba, they'll meet the challenge, or Abloy. That's a good question. I don't think that would be a problem. And again, it depends on your risk. We felt that it was relevant to disclose this, and frankly, I think a lot of the security community or locksmiths are going to say, We knew about this a long time ago. Nobody really put it together for Medico as a high-security lock because of the result of our research. And so we think it needed to be disclosed.
Barry, question? So the question was, Barry asked, do we think we'll break the ARX pins?
Well, the problem is there's a lot of different ARX pins. Okay, there's not just one, as John King well knows. We've already broken some of them. We have repeatedly demonstrated picking and bumping their cylinders with up to 4 ARX pins in a biaxial lock. And so it depends on a lot of different parameters, and I wouldn't be so foolish as to sit up here and say we'll break all of them. We've broken some of them.
So time for 2 more questions. One right here. So the question is, when you're looking at a lock that's mounted on a door and you'd like to attack that lock, what are the resources available to gather additional intelligence or information about that lock?
We're talking about an M3?
Well, any lock. He
Biaxial
said M3 actually stamps M3 on it. So if I'm looking at
You're
Cabo
talking about
Peaks,
a Medico lock.
No, any lock.
Oh, any lock. That's a pretty wide open question. There's a lot of different ways you can impression it. Barry Wells has become a real expert in impressioning. He'll be here all weekend to answer your questions.
But there's probes, there's tools, scopes, etc., to look at the lock, look at the internals of the lock. A lot of times through visual inspection, I mean, the naked eye is pretty powerful. A lot of the techniques that we've described here don't require bore scopes and other technology. So there's a lot of tools available.
There's a lot of different ways. Frankly, impressioning is one of the slickest.
All right, last question right here.
Oh, lots of problems.
So the question is Mark having trouble with Aloha?
Well, Aloha threatened to pull. Well, Aloha is the Associated Locksmiths of America. 5 years ago, when I first lectured at one of these conferences, they said, if you do it again, we're going to throw you out of the organization because our code of ethics prohibits you from talking about security vulnerabilities other than to other locksmiths or security professionals. Now, I don't think they understand the character of who attends these meetings. And I sent them a long letter and said, look, I'd be glad to discuss this with you, but you guys are basically nuts. Everybody needs to know this information, and I'm not sitting up here picking locks. And frankly, you'd be making a big mistake. So they let it set for 4 years. I think they're going to take it up again this fall. You know, if they throw me out of Aloha, they throw me out of Aloha. But I really believe I'm right, and everybody needs to know. I'm not disclosing information that could be inimical to the national security. I'm pretty careful about what I talk about, and they really need, and I don't know how they now say that you guys are all criminals when Medico has embraced the lock sport community, which Aloha attacked several years ago, as being all people of questionable character. So there's a lot of issues. You know, I've told them I'd be glad to discuss it with them. So I have no idea what they're going to do.
So we're out of time. We are going to go over to wherever the book signing is. At 3:15 we'll be there. We can answer additional questions, and we'll have copies of the books available. Thank you so much for your time today.
We really appreciate it.